Good morning, everyone. Welcome to Autodesk Virtual Academy, brought to you by KETIV Technologies. I'm Nigel Mbayak here, one of the application engineers and customer success managers on the team. And today I'm joined by Nikhil Venkat. Nikhil, how's it going?
Good, Nigel. How are you?
Good, good. Nikhil happens to sit behind me, so I've seen him work on this presentation for quite some time now. Looks really good. Nikhil happens to be the person on the team who is most familiar and the only one certified for Autodesk Moldflow, something we're really proud of, which is a tool that we're starting to support and provide as a solution for our customers and people who aren't our customers yet. So today we're going to be going over some of the features of Moldflow, how it works, what it's really used for, why you might need to use it, et cetera, et cetera. But before we get started, I just want to welcome all of the new people today. There are a number of you I can see in the attendees list that I haven't seen before. So definitely welcome to Autodesk Virtual Academy. We do this every week on Thursday at 10 a.m. Pacific on a wide variety of topics. So sometimes you'll see myself, Nikhil, presenting. You'll see half a dozen of our other friends here on the team also presenting on topics ranging from, basic AutoCAD lines and circles all the way to Nikhil's done some really advanced simulation stuff for us in the past. So there is a very wide range of topics. If there's something you want to see specifically, let me know. I can see if we've done it already, be able to pass you a recording of that. Or, we can go ahead and get that slated for the schedule in the future. So definitely want to thank you all for joining us today. With that, if you have any questions, go ahead and type them into the chat panels whenever you get a chance in your respective viewing windows, whatever that may be. And Nikhil, go ahead and take it away.
All right. Thank you. Thanks, Nigel. And thank you all for joining, all of you new folks that haven't been here before. Special welcome to you guys. Now, as Nigel mentioned, today's topic is going to focus on Autodesk Moldflow. So it is an injection molding software. And so our focus today is going to be largely on injection molding. A quick sort of outline on what we're going to be covering today. We'll cover some, fundamentals, basics, building blocks of injection molding itself, the actual process. And then we'll talk about why Moldflow particularly. So what benefits, what advantages does Moldflow provide for injection molding? And then we'll look at some of the parameters, some of the characteristics that you would need to look at to evaluate how good your part is and how moldable it is, and what the result of that molding process is going to be. We'll then jump into the software and then take a look at some of these same features in the software, and finally we'll round the AVA off with a Q&A session. So, injection molding itself, what is it? I know it's something that doesn't get spoken about often enough. It doesn't get used often enough, but essentially, it is a method to obtain molded products by injecting generally molten plastic materials into a mold, and then that's followed by cooling and solidification. Now, I say generally plastic materials because, again, there's this idea that that injection molding is only for plastic components. That is not true. There is also a metal injection molding process, which, again, Moldflow can handle as well.
Or Jello.
Or Jello, there you go. So the largest focus, of course, is plastics. And typically this is how your plastic components look going into the molding machine. It's a series of plastic pellets, which go into the molding machine, get heated up, molten, and then the process goes on. Now, this is especially suitable for high volume production, so mass production of products with complex shapes. Essentially, these are useful for things that are difficult to manufacture using traditional subtractive methods, right? So again, whether it's metals, whether it's plastics, if you have complex shapes that may or may not be manufacturable with your existing technology, then injection molding is one way you can get around that and actually manufacture those parts.
Absolutely. A lot of toys. You can imagine toys being a very, very popular injection molded.
Exactly. Yeah. Toys, consumer products, your cell phone cases, all that sort of stuff, which are pretty difficult to manufacture without a process like this. As you can see here in the GIF that I have, and for those of you who prefer GIF, I apologize. You can see that the pellets actually go into that green region that you see over there. The pellets get molten, they heated, molten, and then sent through the cylinder into the mold, where there is a cooling and solidification process. The mold then opens and the part gets removed. This is, of course, a standard injection molding process. There is a lot of complexity that is possible with this very process. So this is just a very basic workflow. Now, the main variable that drives flow is the injection pressure. Now, of course, there's a lot of other variables as well included, mold temperature, etc. But the main variable that drives the flow, that helps you determine whether the process is adequate or not, is the pressure. Now, why Moldflow? What is Moldflow? Autodesk Moldflow is a single environment for all the pre-processing and the post-processing tasks as related to injection molding. So you'll be able to set up, for example, your materials and set up your injection molding process, set up the process parameters, etc., all within that same one environment, and also look at the results of all of these, the results of this simulation of the study within that same environment. So this is just this is what the software looks like. You know, you can look at multiple results at the same time. You can look at the same result on multiple studies at the same time, etc. And we'll get into the program momentarily and talk more about this. One of the great features, one of the great functionalities of Moldflow is design of experiments. The design of experiments functionality allows you to study and observe the influence on part quality of, you know, processing, different part processing conditions and different geometry modifications, even though you don't really have a great way of predicting what this is going or what the result is going to be going into the simulation process. So it's a great way to really nail down what needs to be, or rather what you need to have as your process parameters and what can be eliminated as being process parameters. Now, this might sound like, you know, it's a very complex software that's going to take a lot of time to run on your machine and really bog it down. But one of the good features, again, is cloud solving capability. Now, cloud solving provides analysis capability, or it provides the capability to run several analyses at the same time. They also allow you to run, you know, very large jobs in a more efficient manner than it would be if you were running it on your local machine. Since the cloud has significantly more RAM and more memory than your local machine does, cloud solving really can truncate and streamline your entire solving process. Now, part design is something that you don't really get to study, and you don't really get an idea of how good it is until you get to the end of your simulation process, right? So you may have a fantastic design, but if it's not manufacturable in an easy way, if it's not, if you're not able to kind of nail down what the right parameters are, what the adequate parameters are for creating that part, then it's likely that the part itself will not behave as you expect it to behave. So, for example, one of the things that you will see on pretty much every injection molded part is weld lines, right? You're likely to see some kind of weld lines, And a well line is the line, the intersection that is formed when two flow fronts meet head on, right? So as you can see, the two arrows indicate that the meeting happens head on. Now you also have something called a meld line. So the first one was with a W, weld. Second one is with a meld line. And this is something that gets formed when two flow fronts meet and flow in the same direction, right? Now this is important because typically these well lines and meld lines are the regions where the part is the weakest. And so when you do finally analyze the performance of this part, you're likely to find that this well line is where the part is going to fail first, right? So there are ways you can get around that, but if you cannot, then the basic idea has to be to minimize the impact of the well lines, and also to make sure that they're in areas that are not necessarily critical. Now, another way you evaluate part design is by studying what is called hesitation. Now, hesitation is nothing but slowing down of the flow front. So as you can see on the first image here, on the top image, the gate is actually closer to this rib. And so if you notice here at the top of this rib, there's no flow. Not very little, but there is no flow whatsoever. Now, one way you can go ahead and fix that is by choosing a different gate location, and a gate further away from the rib is going to lead to some flow in that at the top of the rib there, right? One other way you can do it, one other way you can limit or reduce hesitation is making the wall thickness itself as uniform as possible, right? So when you to summarize with hesitation, the two things that you would look at is wall thickness and, of course, how far or how close the gate is to thin features. The further away, the better the flow is going to be. Now, as I mentioned earlier, one of the big advantages of injection molding is batch manufacturing, batch production of parts. So when you're producing parts in batches, high volumes, you are likely to, well, not likely, you want to definitely make sure that all the parts have the same kind of strength, same behavior, etc. Right? They need to be consistent across the parts, or it's going to be hard to get them through the QA process. So when it comes to injection molding, one way that you would ensure this is by ensuring that all the flow paths within a specific mold are balanced, and that when you have a mold with several parts like this one, you do want to make sure that that each of the parts in there have pretty much the same amount of, or take pretty much the same amount to fill up and have the same amount of pressure, etc. And that's one of the primary ways to ensure that that the parts are actually or as close to being identical as possible. Now, similarly, another thing that you can absolutely look at to ensure that your part is designed correctly and that the flow is adequate is looking at the pressure gradient. Now, the most efficient filling pattern has a perfectly constant pressure gradient, but of course, there is no such thing as perfectly constant in reality. And so the intention is to get as close to a constant pressure gradient as possible. As you can see, this curve here is fairly smooth. There are some slight ups and downs here, but for the most part, you can consider this to be a constant pressure gradient. The only areas where you see pressure spikes are at the start and at the end of the process, and that is expected. if you see pressure spikes in between during the filling process, then that typically indicates that there is a problem with the flow balance. Okay. Now let's jump into the software itself real quick. Oops. Let me move this over. Okay, there we go.
So let's just preface this too. It's like Moldflow is a completely separate application than the design application. So you would design something in Inventor, and then you'd go ahead and then analyze how this would work in your injection molding via opening Moldflow, which is a different piece of software. Just wanted to make sure that was clear.
Yep, exactly. So it's a separate piece of software, it has its own license. And there are multiple flavors of this as well. I don't want to get into all of that right now. So if you're interested in learning about some of the different flavors, versions, I guess, of Moldflow, then feel free to reach out to one of us, and we'll be able to help you with that. But what I have here is actually a really, really simple, simple looking part, right? So it's a thin wall structure. It's got a couple of these ribs here, but other than that, it's a very simple part, right? Now, if you notice here on the left, I've got 3 different studies on the same part, right? So it's the same snap cover, but I have 3 different studies going on it. The reason I have 3 different studies is because I'm not quite sure what the best gate location is going to be. So the first one has a gate at the top. The second one has a gate on the side. And the third one has 2 different gates, and it's also a different type of study. Okay.
And these gates are just where so just correct me if I'm wrong here, is where all of the plastic is entering the mold.
Right,
okay.
Exactly. So the gates are the locations where the plastic enters the mold. And you can specify as many gate locations as you want here to try and analyze what the best configuration would be and the best setup would be. And it's molten plastic, just to clarify. Okay, so this is a study that I already have solved. As you can see, we have a whole number of results here. So some of the quick and easy things that we can look at, for example, are fill time. So if I'm looking at the fill time, I want to make sure that based on the gate location, the time it takes to fill the entire mold is fairly constant, right? I don't want one side filling much quicker than the other side. So if I go into the results, I can look at an animation of this. And as you would expect, this is a symmetric model. So the fill time is actually fairly constant. Now, some of the other things we can look at, I did mention weld lines. So we need to look at where the weld lines get formed. And in this case, the weld lines are the ones that you see over here, the ones that you see in color, right? Now, some of these are, it may seem intuitive that these are going to be the weakest areas of the model, especially regions like this, right? If you've got some experience with FEA, then you'll be able to tell quite intuitively that these regions would be the weakest regions. And this really confirms that suspicion. It confirms that intuition, I suppose. Right, now, another thing, and I didn't talk about this previously, but typically what happens with any injection molded product is since you have a high temperature at the beginning and you have molten material at the beginning and then that's solidified at the end of the process, you are likely to see a ton of shrinkage. Well, not a ton, but you are likely to see some shrinkage in the part because, well, materials shrink as they're cooled. So usually you're designing your mold to a volume that at a certain size that is higher than the actual part size. So for example, I can look at my volumetric shrinkage here and I have a total shrinkage of 12%, right? That's the highest amount of shrinkage that I have in here, which, you know, again, depending on the nature of your process, it might be too high, it might be okay. It comes down to how much, what ability you have to minimize that particular shrinkage. So volumetric shrinkage is one part of it. It's something that you expect to happen in every single molded part, right? Every single molded part, once it's cooled, will shrink a little bit, but that shrinkage should be predictable. If you're molding products, then you need to be able to predict how much the part's going to shrink inside the mold, because without that, you are not going to be able to design the mold correctly. Now, in this third study here, the one with 2 gates, I actually have another quantity that I've solved for, and that is warpage. Now, warpage is warpage is what you really, really want to avoid, right? Shrinkage and warpage are quite closely related. Shrinkage just means that the entire part just gets scaled down, right? The size just scales down throughout almost constantly, almost evenly. Warpage means that there is a movement out of the plane in which it's supposed to be. So, for example, we can see that there is warpage in this region because it's not just that this surface has actually shrunk, but it's actually gone out of the plane and it's kind of lifted up on one end, right? This needs to be minimized as much as possible, because while shrinkage is something that is predictable and it's something you can design for, warpage is something that you need to take into account in your process settings, right? So keep in mind that there are 2 important quantities that you need to look at. One of them is predictable. One of them happens, you know, regardless of how good your process is. The other one, that is warpage, depends on the accuracy and the I guess how good your process is and your process settings are in order to be able to minimize the warpage. Now, as I mentioned earlier, we do have there is the pressure as well. So the pressure, ideally, we would like it to be constant, right? We'd like the pressure gradient to be fairly constant. So in this case, we have a lot of different processes going on. So I don't want to discuss this particularly, but if I go back to just the flow, then I can see that the pressure at the injection location, again, notice how there is a peak and then it all of a sudden drops and then drops down to 0. So this is not an ideal pressure curve, right? This is not an ideal pressure gradient. There are certain things in the process that we would have to go in and improve in order to improve the pressure gradient here. Now, you may have noticed that there are different sets of results in each of these. The reason for that is the way I have this set up, right? So in the analysis sequence, if you look in here, you can, for example, if you don't know the gate location, you can actually have Moldflow tell you what the best location of the gate's going to be. If you don't, for example, if you want to understand what your molding window is, understand the behavior in your molding window, you can have it tell you that. What I did initially was, for the first 2, was just a simple fill and pack analysis, which basically is just the flow analysis, right? For the third one here, excuse me, I also did a cooling analysis, a fill, pack, cool, and warp analysis. right? So depending on how detailed you want to go and depending on what stage of the process you're actually looking at, Moldflow will let you go through each of these individual, sequences, or each of these individual sub processes, and really optimize and analyze each one of those, right? Now, if you have a more complex part, if you would like to understand the cooling a little better, then you can also use the FE, the finite element analysis method, FEA, for the cooling analysis. And this will give you a little more insight, a little more detail as to how that cooling is ongoing. Okay. Now, one of the other things that I think is important to note is that this is entirely CAD agnostic. So I can try and import a model and it can bring in files from Inventor, it can bring in files from KETIV, from SolidWorks, Pro-E, etc. Right? So it's entirely CAD agnostic. So you don't need to have Inventor, for example, for you to be able to work with Moldflow. Another question that we get an awful lot about Moldflow is materials. Plastics, especially, can be quite challenging to characterize. But Moldflow itself actually has thousands and thousands of materials in here, right? The software itself already has all of this built into it, and it is likely that you'll find a lot of the materials that you're looking for in here. Now, if you don't find it, if you've got custom materials, then you can always work with your material supplier, because it is very likely that they also have access to Moldflow, and they will be able to create that file for you so you can directly import it. Okay. Couple of other little things. You do have, like I said, you do have the ability to solve on the cloud. So both meshing and analysis, and it's not going to let me analyze again because it's
already done.
It's already done. It's already solved. You have the ability to do both of them locally or on the cloud. Now on the cloud, again, it's very simple. I was able to solve all three of these in a matter of 20 minutes, I think, on the cloud. On my local machine, it would have had to be sequential, so it would have taken probably a little longer. My machine is also currently, it's got a whole bunch of garbage in it, so it does tend to slow down a lot. So I just go in and start using the cloud really quickly, and it almost always is faster than what my machine can do, because I'm never doing one at a time. Okay. Now, other important things that you can make use of, one is reports, right? So you've got a report wizard that you can use to create a fairly comprehensive report, which you can go in and throw all of this information in, and it's completely customizable. There's also an API functionality that allows you to customize the entire report format itself. You also have a Moldflow viewer, a communicator, as it's called, which allows users to just view the results and the study. They don't necessarily need to have multiple licenses for that. All they need is the communicator, and they can open up the files and start looking at them. Okay. With that, if you have any questions, be happy to take them now.
Cool. Yeah, we definitely do have a couple of questions, Nikhil.
Sure.
that have come through. I personally have one. So generally, and I've been with you for a lot of FEA sessions in the past. I personally haven't delved too deeply into Moldflow. What are the boundary conditions, the initial conditions you set besides just the model? Do you set, like, obviously set material? Do you set like the size of the inlet opening? What kinds of things are generally like applied?
So generally, the things that you would specify are the injection location. So that is an absolute must. You need to specify that.
Absolutely. Figured.
Yep.
It won't fill unless there's a place for it to do so.
Exactly, right. The next thing you need to set up is, of course, the type of analysis. So ensure that you're choosing the analysis that gives you the information that you need.
Yep.
And by default, there are some process settings that are going to be in there already. But if you had your own molding machine, for example, with its own settings, you can put that in.
Oh, for like the temperature that the
Yep.
plastic is at when
Yep.
it gets injected and stuff like that.
Right. So the melt temperature, the mold temperature, how, you know, what the cooling time is going to be, etc. Right.
Very cool.
So you can specify all of that. Most of these are defaulted to some value, like the mold surface temperature is 88 Celsius. That's the default. 282 default. But again, if you had more advanced information going in, then yes, you would have to set that up as well.
Mm-hmm. Very cool. Very cool. Someone had questions like, you keep mentioning you want the pressure to ideally be constant. Maybe it's the pressure gradient.
It is
right?
the pressure gradient.
So can you explain that a little bit?
Yes. So actually, I can do that right here. So if you basically what you're expecting to see is that the pressure is going to keep increasing, right? As the mold fills up,
Right.
and you're trying to inject more molten plastic or
It needs to
molten
become
material
more
into
difficult to do so.
Right. It becomes harder to do so. So the pressure at that injection location keeps increasing. Now, you want that increase to be predictable, and you want that increase to be gradual. You don't want sudden spikes in here.
Mm-hmm.
Sudden spikes are going to lead to air traps, which are of course going to lead to, you know, areas of weakness. So air traps lead to well lines, and well lines lead to weakened areas. So as the pressure increases, you want that to be gradual, and the only time you should see pressure spikes are when it initially starts injecting, and once the
Cavity is full.
Once the cavity is full, right? At that final point, you know that the pressure is going to be maximum, and that's when it gets ejected, or it starts cooling and then gets ejected.
Cool.
So,
yeah,
it is
so
the
it's not
pressure
it's not a pressure that's the same. You want it to be increasing at the same slope.
right.
Cool. Makes sense. Yeah, like that graph showing there.
Yep.
So hopefully that answers that question. Let's see. Is Moldflow in the product design and manufacturing collection? Nikhil?
No, Moldflow is not in the product design and manufacturing collection. As Nigel mentioned earlier, it is a separate product by itself. And there's a reason for that. It's not in the collection because as you can see, it's quite specialized, right?
Yeah,
it's
part of like the advanced manufacturing stuff.
Exactly. So it's not something that you just sort of plug and play and you know exactly what's going on there. So to answer the question, no, it's not part of the collection. But it does work with, this is one thing I didn't mention, but it does work with several products that are already inside the collection, namely Inventor and Inventor Nastran and Fusion, etc.
Absolutely. And there, you know, there's a lot of components to the advanced manufacturing offering from Autodesk, right? So Autodesk has been making, I wouldn't say fairly large, I would say significant investments in the advanced manufacturing section of, you know, the design manufacturing business. And so they've acquired a lot of technology over the last couple of years, spending, I don't even want to know how many zeros are on the end of some of those numbers, to obtain a lot of this technology that they're, you know, optimizing and providing to the users. Yeah, so with that, you know, Nikhil can pull it up on his screen too.
Yeah.
and I'm sure Jessica put the link in the page as well, is, we do focus a lot in the advanced manufacturing. So when you're looking at some of those true products, some of those really advanced CAM products as well, maybe you need to go a little bit further than what HSM provides. And you guys are making things that are super complicated, say, I don't know, aerospace. You would look at some of these tools. We have a lot of content. We're doing a lot of webinars related to advanced manufacturing techniques, whether it's Moldflow, whether it's CAM, whether it's something else. If you go to that web link, you can get more information on all of the events that we're holding, and it's a lot of stuff. So have at it. I've got a question here from Fernando. How do you determine what values to use for the pressure? Do you understand what he means by that?
So
the pressure is generated by the machine and the mold. You don't apply the pressure. I mean, I guess you apply the flow.
Right. No, but I mean, that's a question we can definitely talk about offline. I think it deserves a
there's a full conversation around that, right? It's I think a lot of the constants for this is like things that are from your machine.
Exactly.
So you need to understand, like, okay, like, how am I filling this? What machine am I using to do this? And then that'll give you some of those initial conditions, right? So how hot everything is, the flow rate, I'm assuming, of the liquid as well. And molten. I don't even know if
plastic. Or
yeah.
metal.
So if you want to know more about that, Fernando, let us know. We can go ahead and have a specific conversation with you around what that is. What else for Moldflow?
Just to going back to that page for a second, today's session will also be posted on this.
Yeah.
So it's ketiv.com/advanced manufacturing. Make sure you bookmark this page so you can, if you're interested in advanced manufacturing, you'll see this constantly being updated and you'll see new videos pop up.
Yep, absolutely. Yeah, this is all being recorded. Yeah. So happy whatever day it is for those people watching this in the future. So everything that we do is recorded. So if you're looking for any of that stuff, feel free to go ahead and browse our YouTube channel or just reach out to one of us. We'll be able to give you links to exactly what you need. Just thoughts from everybody. What do you think about today's session? Is Moldflow something you guys are going to use in the future? Go ahead and type yes. Go ahead and type no. I don't know in those questions, and I'll go ahead and, that gives us an idea of how useful some of this was to you guys. And what we should do in the future is are you guys doing injection molding? Are you guys doing subtractive manufacturing? I know advanced subtractive manufacturing is something a lot of people are interested in as well. Nikhil's maybe not the guy for the subtractive manufacturing. We do have some specialists on the team though. So looks like a couple people it'd be useful to them. Some people not so much. I see a lot of people when like we were talking about earlier, right? Consumer products, it's a really big deal, especially if it's like electronics and stuff, right? And you're looking at quality control for those things, right? It's like the last thing I want to do is go to the store, spend a bunch of money on some medical device per se, and have it be like have a bunch of holes in it or like a bunch of pores in it. It's like, wait, why did this break? This thing got manufactured incorrectly. And things like Moldflow, things like some of these other and I would consider this a simulation software, right? An analysis software are useful for helping prevent those things. I think the last thing you want is a bunch of warranty issues to come back, right?
Exactly, right.
So
especially when you're talking about, high precision applications.
Absolutely. Med devices, big deal.
Yeah.
Anything that goes into space, also big deal. So, all right. Looks like a lot of people are saying it'd be very useful for them when designing their parts. I'm be curious to know, like already, those people who are designing products for, some of those consumer products, some of those medical device items, some of the other things that require things like injection molding or casting, so on and so forth. Do you design your parts with that in mind, or do you just design them as to like, this is exactly what I want, and not really worry about the manufacturing process? It'd be really interesting to note where you fit in that span, because I know some people, they just design like, this is what we need. This, like, for example, I'm looking at Nikhil's mouse right now. This probably to mold it. So it's like, did they design that mouse with the shrinkage in mind, with some of that other information in mind, or did they just send it?
That's a really good question.
All right. I'll give everyone another 30 seconds or more, or 30 seconds or so to ask any questions you do have. Nikhil, again, thank you for being a part of today's webinar. If anyone else has any suggestions for stuff to Nikhil to do in the future, anything simulation related, anything general inventor related and AutoCAD related, Nikhil also is, you know, he does a lot of instruction on those activities as well.
Not AutoCAD.
That's true, not AutoCAD. That's true. But inventor related.
Yep, inventor, absolutely.
Absolutely. And then I'll make a couple of announcements for some of the AVAs here coming up in the next couple of weeks. So next week, we're going to be going over another tool in the collection, not another tool in the collection, a tool in the collection, because this is not in the collection, called Navisworks Manage. It's kind of a model aggregation tool. Sometimes you have very, very large models from different not business groups would say, different sectors of the design process, right? Maybe you've got someone is commissioning a full building and you designed the actual building. Someone else designs the HVAC. Someone else designs the electrics that go in there. And you want to be able to aggregate all those models together without making something so heavy you can't manipulate it. Navisworks is a tool for that. And we're going to be going over some of that next week with Jeff Perez. And then the week after, we're going to be going over some iLogic with Eric, which is, I'm really excited for that session. We're going to be going over some of the operators in iLogic. So things like and, or, nulls, some, I guess, Boolean stuff with Eric and how to use all of that to be able to manipulate your data in the way that you need it to, you know, do all that fun stuff. So cool. Looks like some people are asking, it's like, hey, maybe we want to see some stress analysis in Inventor. Maybe we'll do some Inventor versus Inventor Nastran stuff. We'll take a look at that.
Yeah.
Cool. Looks like that's it for questions. With that, Nikhil, thanks again for being here. Everybody, thanks for joining us today. If it was your first day here at AVA, definitely would appreciate feedback on how you think the session went, you know,
yeah,
how useful this is to you guys. So again, thanks everybody for joining us today. We'll see you again, same time, same place next Thursday. Adios, everybody.
Thank you all.